in order to remind us, even though you were going quickly, that we needed to be careful of how we noted it. What am I not writing? I'm not writing equals infinity over infinity, and I'm not writing equals 0 over 0, right? So in even the multiple choice, even the short answer, even when I look at your Google Classroom homework that is submitted by the end of the day today, because for some reason there are multiple ones of us, I've heard of 2 to 3 to 4 to 5 that didn't submit. There are multiple ones, like all over, and we have people absent. Okay, coming back. Get it in by the end of the day. But we are showing arrows because limits approaching infinity technically is not an equals. Or 0 over 0 is not an equals. It's not an actual answer to it. But what are we also doing? Deriving and rewriting that. Remember, they took off points too if you did not rewrite the limit. Every single time, technically, they didn't take off points for that, but it has to at least be written. Ooh, it's a new derivative, a new derivative. You better rewrite it. Okay? But to that end, let's go ahead and go grade the evens. Go over questions that we need to. Hold on, though. Oh, I'm going backwards. Los Santo, wrong direction. Was number 55 a homework question? Yeah. Was number 64? Okay, can we talk about these real quick? Because previous years have had questions on them. Is that okay? Okay, let's start with number 55. Thank you, Isa. Can you erase the 8 also, or erase the 8 also? There you go, and write them both. Ooh. If that was true, I'd... No, you got this. You can do numbers. You can do numbers. You can do... Okay, as they fix the front, remember the whole, like, we're actually being productive. What do we think about? This is a great question. Super basic Calc AB besides needing L'Hopital's, which is still technically Calculus AB. What do you guys need to think about if we need to make this continuous? Why? If this is an FRQ. Okay, what's the definition of continuous? Do I need to worry about one-sided limits? Why not? There's not a less than 0, greater than 0. There's just a not equals, which is both less than and greater than. Does that make sense? So this is both sides. Could be. What do I need that to equal? Okay. What do I need this to equal? F of 0, which is? Does that make sense? So what do I need to do? Why? Why L'Hopital's? You can't just jump there. You have to have a reason why. Because L'Hopital says the limit must produce an... Okay, so is it indeterminate? Why? Do I need to worry about talking about the continuity, differentiability, any of that jazz? Because they're just normal elementary functions that I know the continuity of, right? Okay, so I can say L'Hopital's applies, which they spell the hospitals. So we're going to rewrite the limit because we know we have to. And what do we do to the top? Which is 9 minus? Which? What's going to happen? Right? What am I going to have? 27 cents? Dilemma. Positive, I think. You checked it in the back, Isa? Ooh. So much love. Is that okay? Are we okay? Notation-wise? Process-wise? The whole thing-wise? All right. Number 64 is where we're going next. It's an even, and you might not know if you got the right answer. And it's a multiple choicey one. You ready? Ready, set, let's check, and then we're going to grade the rest. Which of the following gives the value of? What's wrong? There's a lot wrong? Why is the answer C? I just did it in my head, but how'd I do it? Maybe. Okay, why would we be doing a derivative? Okay. This wasn't a big deal, was it? What's over secant squared? What's cosine of 0? But how did I do it in my head? I actually didn't do that. I did the limit as x goes to 0 of x over sine of x all over cosine of x. And I was like, okay, isn't that the same thing as cosine of x over cosine of 0 is 1? Well, we know the special trig limit, and it actually ends up working the other way, too. So x over sine of x goes to 1, and cosine pops up. Both ways work. Both ways work. Well, that's when you have to think about secant. That one, I just thought x over sine of x. I'm like, that's 1, cosine of, and I popped cosine up. So I didn't actually do all of that in my head. Well, sometimes you're right and sometimes you're not. All right. To that end, before that, let's go grade. Here we go. Number 6. Did you guys get 1/4? All right, we're grading. This little group is so cute, but focus. Okay, 6 is 1/4. Number 20 ends up being 2. Wait, sorry. 2 was the limit, but you have to take, ln of 2. Lo siento. The answer key loves to take it piece by piece. This is that limit property. You can take the limit of the inside and then do the outside. Sorry, ln of 2 is the final answer. Good job. 24 is 1.
My indeterminates are great. I'm indeterminate.
Well, that's good. It's good that you know it's indeterminate. Yeah. Did you have, well, Ariane, this is your trick, right? I'm calling it yours. What do we do if we have multiplication and we need division? Divide by the reciprocal. Divide by the reciprocal. Makes all the difference. We talked about that a couple times on Friday. Number 36 is 1. Number 44 is 1. Don't just randomly guess 1 because you see it a lot in homework. Number 60A is 0. But 60B is still 0. 64 is 1. 64 is C. 66 is B. And then we're done. All right, what questions do we have?
You know what? There's just like everything. So they want to go ahead and try it again.
Maybe a 0 period tomorrow? Okay. 39? Same? 25? 56?
Can we go over 15? This might be dumb, but I just don't get it.
We have quite a few, actually. So what do we have, 15? Yeah, 25 and 39, right? Wasn't there another one? 56? Do we have anybody that can do anyone's?
I can do none of them. Yeah. Oh, I can do. Oh no.
We're looking. Okay, if I can beat you doing all four, I'm going to start backwards. I'm going to start at 39. If you guys have one, go up to the board, and then whatever's not done, I'll keep going. I'm going to pause, though. People don't need to hear us. 39, as far as I can tell, in all the work that I've done, I'm pretty sure the answer is negative infinity. So, yeah.
Say you're wrong, book.
I need to look and see if they have any extra insight, but right? It is 0 over 0. Approaching 0 over approaching 0, whatever you want to say. Oh, no. They caught me. Who sees it? Charles was not legal. It's not indeterminate. 1 minus 0, that's 1. You're supposed to plug in now. What happens if you get closer and closer to 0? Well, that's still a positive because 1's going to win, and closer to 0 from above, that's positive. A positive over a positive is what kind of infinity? Charles was never able to be used. That tricks me. Stink. Doesn't usually happen. It's okay. It's a good lesson. Any of us can get tricked at any time. 1 minus 0 is not 0. And I was giving poor pre-cal kids a hard time today. Over and over and over and over. Because I was like, math. Oh, by the way, the quiz I just graded, math. Because this is what I had to mark wrong. On people that got 12 out of 10s and people that got 4 out of 10s. They did this. Math. 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 Yeah. No, I pointed out lots of math today. Just math. Anyway. All right, guys. This section doesn't have to be hard unless you make it hard, okay? Without going into tons and tons and tons and tons and tons of detail. This is exciting. I love this, but we'll go ahead. I actually really like this. We'll come back to this. We'll get the bare bones today. Okay, relative rates of growth. The point of section 9.3 is to talk about how one function grows in relationship to another function. Okay? That's the long story short of today. You guys already wrote down or already read comparing growth rates using L'Hopital's rule, relative efficiency of sequential and binary search algorithms. This is what I think is kind of interesting out of the whole shabam. Some of this is going to seem really silly, as in like, duh, but some of it's going to be a little bit confusing. So as we talk about relative rates of growth, and I'm not talking about related rates. Okay, related rates is a very specific type of word problem where you have different quantities moving at different rates. This is just specifically talking about who is growing faster, who's growing slower, and are they growing at the same rate. And if you guys notice down here, it's just basically terminology to what answers you're getting from limit problems, limit quotients, I should say, limits of quotients. So when you're taking the limit of a rational function, rationals are technically polynomials over polynomials. When you're taking the limit of some sort of quotient, and you get infinity, what does that mean? If you take a limit of another quotient and you get 0, what does that mean? Okay, so what we're talking about in this one is faster, slower. Does it make sense that the limit to infinity of f over g equaling infinity means that f is growing faster? It does, right? F is growing faster over g is growing slower. Now, you're like, okay, degree of the top must have 1 over degree of the bottom. Yes, but this is a more specific application. So when you get a limit of a quotient equaling infinity, the top is going faster than the bottom. Or if you get a limit to infinity equaling 0, who's growing faster? The denominator, yeah, exactly. Whatever function is in the bottom. And then we have here number 2, if you get the limit to be a constant, we can specifically say not just, oh, the degrees are tied, but specific application, what's true about these two functions? Exactly. Okay, so that's a further application of limits than we've done before. So in this one, before we go to the transitivity of growing rates, our note, don't worry, transitivity, transitive property, it's something you've seen before, kind of. F grows faster than g means that for large x values, g is negligible in comparison to f. So when you have one function growing faster than another, we'll just leave it with function right now. When you get sufficiently large values of x, that's a mathematical way of saying it, when you get sufficiently large, ultimately g is negligible, which is why we can say the limit will be 0 if the degree on the bottom is greater. Not because if you plug in for 1 and 10 and 100 and a million, you're going to have a number that's 0, but eventually, for sufficiently large values of x, which can be totally different based on the problem that you're given, but eventually, one will be negligible in comparison to the other because the one eventually is growing faster, which is pretty crazy when you think of something like we talked about in section 9.1, 100 to the power of x, or 100 to the power of n over n factorial. Why is that one a bit mind-boggling? 100 to the 1 is 100, 1 factorial is 0. 100 to the 2 is 10,000, 2 factorial is 2. 100 to the power of 3, 3 factorial. Does factorial win? It takes a long time, but eventually it catches up because it's growing faster. It doesn't look bigger. It doesn't look bigger. It makes no sense if you didn't have those special sequences to think about. You're like, no, 100 to the power of exponential growth is the fastest growth we have. Factorial growth is greater. So eventually it'll catch up. Transitivity of growing rates. If f grows at the same rate as g, as x goes to infinity and g grows at the same rate as h, do you guys kind of remember the transitive property now? If f is the same as g and g is the same as h, then f is the same as h. Now, I technically show a little bit of a mathematical proof as to why. It's not a huge, huge deal that you guys get this down as far as the, I guess mathematical illustration might be a little bit better way of saying it. They're saying, okay, well, if it's the same rate, then that ratio will be a constant. The limit of that ratio will be a constant. The limit of that ratio will be a constant. If we go ahead and do f over h, we could go ahead and show f over g, g over h. Like, it's very mathematical in the sense of it will be a constant also. But I don't necessarily think you guys need to write that down. So what does this mean? If you see something in homework that says show that e to the x grows faster than the given function, you have two different options. You can either put e to the x in the numerator or e to the x in the denominator. If you put e to the x in the numerator and he's growing faster, well, you better show that your limit is equal to infinity. If you put e to the x in the denominator, no big deal. Just show that your limit goes to 0. What do you guys want to do? Top or bottom? Okay. So if going to 0, x is approaching infinity, our goal is 0. Do you guys see how this would make sense? Why does the bottom win? But why? But why? But why? How could you show it to me? Opie tells. Because what would happen if you keep on deriving? This guy is going to eventually end up getting 2 without us showing all the here like the reasoning behind it. Isn't this going to eventually get to a limit as x goes to infinity of 3x squared, 6x, and 6? 6 over e to the x. Remember, he's just as strong after deriving. That's why the AB sweatshirt is a little bit funny with the whole Pokemon thing, if they eventually get it. They're putting in orders today.
They got a Pokemon sweater. I didn't get it.
You're joking.
Not today. Yeah. It was like a wild exponential function appears, and then you use differentiate, and then it's not effective or something like that. If you want one, let me know. Let me know. Let me know.
Yeah, that is my entire childhood.
Well, it's just right here. It's AP Calc AB, just like the little screen print.
But I played Emerald.
Hi, shh, equals 0. Number 5. Ln x grows slower than the given function. It's up to you guys. Ultimately, you just have to choose. Make a ratio. Where do you want ln, top or bottom? Okay, so on top. Long story short, you make a ratio in some way, shape, or form. What happens if you make a ratio in some way, shape, or form? That goes to infinity, that goes to infinity, that goes to infinity. We're just confused all over, right? How do we go off? L'Hopital?
Do we have to show all the steps, or can we just like skip some?
I don't mind if you're skipping, as long as you're doing it legally. So if we have one, yeah, I told you the actual practice of it isn't that bad. You're basically practicing L'Hopitals and putting in some new terminology along with it. What ends up happening? Because what's 1 over infinity? 1 over infinity. What's 0 over 1? Cool. Does that make sense? Okay. So I think we're okay, because what's our goal? What's our aim in numbers 9 and 13? Same rate. You should end up with a limit equaling a constant. If you didn't, something went wrong. Yeah?
Any constant?
Any constant. That doesn't equal 0 or infinity. How about number 31? What's going on? Can't you just do that one with that one and that one with that one, and then we're good? Because the transitive property says, okay, fine, all 3. So we need to put a ratio. Now, guys, does it technically matter what way you do the ratio? No, because you should be able to read it either way. But ultimately, they should all end up, any combination of f over g or f1 over f2, f2 over f3, f1 over f3, what should happen if they're all growing at the same rate? Their limit should equal a constant that's non-zero, right? Okay, so what's this whole last thing? Don't worry, it's the very, very last thing. Algorithm efficiency. Algorithm. What uses algorithms these days? Calculators, computers, whatever you want to say. Anything with technology, basically. Anything with programming. Programming is algorithmic. Efficiency. What makes an app good? Well, there's a lot of different things. However, there be multiple different ways of programming in order to reach a desired end. Most definitely. The bane of the existence of a lot of comp sci. What makes the programming efficient if it has been done in the future? Because I think it's hard. Or works long. So if this idea of efficiency is practical, which it definitely is, you could have multiple apps taking away all the graphics and all the user-friendly and all that sort of stuff. 2 different apps do the exact same thing. What makes you choose one over the other? Well, I know there are ratings, etc. But the most efficient one, and specifically speaking in this case, it would be the one that crashes least, which theoretically is programmed more efficiently than the one that crashes more. Sequential versus binary. If you were to want to get to a certain word in the English language, and if you were to try to program if you were to try to program a computer to try to find said word, so that the user inputs a word. And let's say the user inputs something like clown, and they want to find the definition of clown. And this computer has in its database the entire Webster's dictionary, okay? Let's say you just said it and sent it searching for, okay, clown, take the first letter that was input and then go through the entire dictionary until you find that first letter, C. Then go to the next letter, L, and then go to the next letter. That would be a sequential search. I just keep on going forward through the list until you find a C, and then you find an L, then you find an O, and a W, and an N, then stop and be like, oh, hey, it's the word. However, what if the person was to ask for something like zoo? How hard is that computer working? How many different words is it going through? Tons. A binary search makes a lot of sense. A binary search says cut the dictionary in half, however many words, go in half, and say, hey, does the word go before or after that? Clown, oh, it's before, cool. Cut in half again, before or after that? Oh, before. Cut in half again, oh, before. Cut in half again, oh, after, take that one. Cut in half again. The steps are much fewer. For a list of n items, a binary search is at most, I believe it's log base 2 of n.
I was like, what?
I think it's log base 2 of n. I might be wrong, but I think it's log base 2 of n, as far as how many steps it would actually take, as opposed to thinking about how many words are in Webster's dictionary. The maximum number of words would be the entire dictionary if someone chose the last word. Now, all of that to say, you're not going to actually have to program anything tonight and see how efficient it is, which would be very interesting, but much beyond the scope of this class. But if they do say something like, hey, suppose you have all these different algorithms, which one is the most efficient? What are you looking for? The most efficient. You're looking for the greatest one or the smallest one? Smallest. Bye. The most efficient as in the growing the slowest. Limits. Limits. As n goes to infinity, which one is growing the slowest? Which one is the smallest? The least magnitude.